Example 2. Suppose that the sine of theta is equal to 3 over 4 for the acute angle theta. Evaluate the secant of theta. All right, how we're going to do this is what we're looking for is the secant. Now, in order to get to the secant, we need to know what the cosine is because the secant's reciprocal function is in fact the cosine. And what I'm going to use is I'm going to use the fact that if the cosine is x over r, then the secant is r over x. Remember the radius divided by the x coordinate. And the sine is y divided by r. All right, so let's draw a picture of this. We're over here in quadrant 1. All right, here's our acute angle. This side over here is going to be 3 because that measures the distance up. The hypotenuse here, this is going to be our radius of 4. We do not know what x is. Okay, so right now what I have is a right triangle where I know 2 sides and I need the third side. And so this is going to be a case where I need to use the Pythagorean theorem. A squared plus b squared is equal to c squared. All right, so we have x squared plus 9. This is equal to 16. That means x squared is equal to 7. And when we square root both sides, that's going to give me the square root of 7. And since I know the secant is equal to r divided by x, well, r we just said was 4. X we just found to be the square root of 7. Let's rationalize this denominator right here by multiplying by the square root of 7 over the square root of 7. This is going to give me 4 square roots of 7 over the square root of 49, but I know the square root of 49. So this is going to give me 4 times the square root of 7 over 7, and there's our secant. Example 3. Evaluate the cosecant of 45 degrees, the secant of 45 degrees, and the cotangent of 45 degrees using a triangle. All right, so let's draw our triangle. And we'll put our 45-degree angle down here. Now, from the unit circle, we know that the coordinates of our triangle are square root of 2 over 2 and the square root of 2 over 2. And of course, we know the hypotenuse to be 1. All right, so the cosecant is defined to be r divided by y. In this case, that will be 1 divided by the square root of 2 over 2. This turns into 1 times 2 over the square root of 2, which is just going to give me 2 over the square root of 2. And then I'll multiply by the square root of 2 over the square root of 2 so I can rationalize that denominator. This will give me 2 times the square root of 2 over the square root of 4, but I know the square root of 4. It's 2. So we have 2 times the square root of 2 over 2, and it looks like these 2's are going to cancel, and the cosecant is just going to be the square root of 2. The secant is going to be defined to be r divided by x. That's going to be 1 over square root of 2 over 2. And we're going to have the exact same problem here. So we would go through the very same steps and arrive at the conclusion that the secant is also going to be the square root of 2. All right, the cotangent of 45, this is x divided by y. That means we're going to have the square root of 2 over 2 divided by the square root of 2 over 2. Well, this turns into the square root of 2 over 2 times 2 over the square root of 2. Let's see, the 2's are going to cancel, the square root of 2's are going to cancel, and all we have left are 1's all around, so looks like the cotangent is going to be 1. Example 4. Let's evaluate the sine of 30 degrees, the cosine of 30 degrees, and the tangent of 30 degrees using a triangle. Alright, let's draw our picture. We've got a right triangle, and we can put our 30-degree angle down here. Alright, and let's see, we know the radius is 1, and we know that the coordinates are positive 1/2 and the square root of 3 over 2. And in this case, it does matter. The 1/2 does have to go across from 30 degrees because we have a theorem in geometry that says that the smaller angle should be across from the smallest side, and 1/2 is 0.5 as a decimal, and square root of 3 over 2 is 0.87 as a decimal. So it is larger, which means it should be across from the 60-degree angle here. Okay, to find the sine for 30 degrees, all right, we can do SOHCAHTOA here, opposite over hypotenuse, or we could do the fact that the sine is y divided by r, but in either case, 1/2 is the sine of the side that's across from the angle there. The hypotenuse is 1, and let's see, this turns into 1/2 times 1, which is just 1/2. The cosine of 30 degrees, this is x divided by r, or adjacent divided by hypotenuse, so we got square root of 3 over 2 divided by 1, which is the square root of 3 over 2 times 1, and then that's just going to give me square root of 3 over 2. The tangent we're going to have to work a little bit for, because the tangent is opposite over adjacent, or y divided by x. The opposite side is 1/2. The adjacent side is square root of 3 over 2. This turns into 1/2 times 2 over the square root of 3. And our 2's are going to cancel out. This is going to leave me with 1 over the square root of 3. And then let's rationalize that denominator. So we're going to multiply by the square root of 3 over the square root of 3. This is going to give me the square root of 3 over the square root of 9. But I know the square root of 9. It's just 3. So the tangent is going to be the square root of 3 divided by 3. Example 5, we're going to simplify these expressions. In part A, we want the cotangent of 60 degrees minus the cotangent of 30 degrees. Alright, if we look on our unit circle at 60 degrees, and remember the cotangent is defined to be x over y, we will find this is going to be 1/2 for x divided by the square root of 3 over 2 for y, and we are going to be subtracting the cotangent at 30 degrees. Now x at 30 degrees is square root of 3 over 2, and then y at 30 degrees is 1/2. Alright, let's see, this is going to give me 1/2 times 2 over the square root of 3 minus the square root of 3 over 2 times 2 over 1. Alright, let's see, it looks like our 2's are going to cancel. So now I have 1 divided by the square root of 3 minus, and it looks like the 2's are going to cancel, the square root of 3. Alright, let's rationalize the denominator on this fraction. This is going to give me 1 divided by the square root of 3 times the square root of 3 divided by the square root of 3. And then we're subtracting the square root of 3. And I'm just going to put a 1 under here so we can see what the denominators are. Alright, this is going to give me the square root of 3 over the square root of 9 minus the square root of 3 over 1. And then I know the square root of 9. So we have the square root of 3 over 3 minus the square root of 3 over 1. And we don't quite have a situation where we can combine these. So we need a common denominator down here, and I'm going to use the cross multiplication method here. 1 times the square root of 3 is the square root of 3 minus 3 times the square root of 3 is going to give me 3 square roots of 3. And then in the denominator, 3 times 1 is going to give me 3. So again, what I did to get that common denominator, I just multiplied in an x here, kept the negative sign in the middle, and multiplied the two denominators together. Now I actually have like terms. So I have, hang on. All right, now I actually have like terms, and I can combine these, but we're not going to mess with the square roots of 3. We're only dealing with the numbers on the outside of the radical here, and there's an understood 1 to be there. So 1 minus 3 is going to give me negative 2. We'll hang on to that square root of 3, and then we keep our denominator there. All right, so this expression simplifies into negative 2 times the square root of 3 over 3. All right, for b, we're going to do the sine of pi over 3 times the cosine of pi over 6 plus the cosine of pi over 3 times the sine of pi over 6. Now, if we take a look at our unit circle, the sine at pi over 3 is the square root of 3 over 2, and the cosine at pi over 6 is the square root of 3 over 2. The cosine at pi over 3 is 1/2. And the sine at pi over 6 is 1/2. So the square root of 3 times the square root of 3, this gives me the square root of 9 over 4 plus 1 over 4. And the square root of 9, I know, it's 3. So we have 3 over 4 plus 1 over 4. And that simplifies to 1. Example 6. For each function value, find a cofunction with the same value. Okay, first one, the tangent of 22.5 degrees is equal to the square root of 2 minus 1. So we're going to keep this side. We're looking for the cofunction of this side right here. All right, the cofunction for the tangent is the cotangent. And the angles for the cofunctions are complementary. That means that 22.5 plus the angle of the cofunction over here should equal 90 degrees. So we can say the cotangent of 90 minus 22.5 is also equal to the square root of 2 minus 1. And then if we simplify this, we'll find out that that angle is actually 67.5. So the cotangent of 67.5 is equal to the square root of 2 minus 1. All right, now for part B, we're looking at the secant of pi over 3 equal to 2. Again, we're going to keep this. We're looking for the cofunction for the secant. Well, the cofunction for the secant is going to be the cosecant. And remember, the angles of the cofunctions are going to be, they're going to add up to 90 degrees, only in this case, they're going to add up to pi over 2, because pi over 2 radians is 90 degrees. So the cosecant would be pi over 2 minus pi over 3. This will give me the complementary angle that goes with pi over 3. All right, let's see. We got to do a little work over here. If we get the common denominator, pi over 2 minus pi over 3, and I'm going to do the little cross multiplication trick here. So this is going to give me 3 pi minus 2 pi, and this is divided by 3 times 2, which is going to be 6. So 3 pi minus 2 pi is going to leave me with 1 pi, and then we keep our denominator. So it looks like the cosecant of pi over 6 is going to be equal to 2. Example 7. Suppose that a farm worker determines that the distance along the ground from her position to the base of a palm tree is 16 feet. She measures the angle of elevation from an eye level of 5 feet to the top of the tree as 45.9 degrees. Is the tree tall enough to harvest at least 20 feet tall? Now, this should be an M right here. All right, let's draw our triangle. We've got our tree height right here. All right, let's see. The distance along the ground from her position to the base of the tree is 16 feet. So that means that the farmer is going to be standing right here, because remember, this is our tree. All right, the angle of elevation, that's this angle right here, 45.9 degrees. And we need to know the height of the tree and if it's tall enough or not. Well, let's see. We're going to use SOHCAHTOA. All right, the sine, opposite and hypotenuse, the cosine, adjacent and hypotenuse, the tangent, opposite and adjacent. Here's my angle. Here's my right angle. This is the hypotenuse. This is the one I don't know anything about, so I can throw out this one because it has a hypotenuse. I can throw out this one because it has a hypotenuse. That means we're going to be using the tangent. All right, so the tangent of my angle, which we know to be 45.9 degrees, is going to be equal to the side across from 45.9, x, we don't know that, that's what we're looking for, divided by the adjacent side, 16. All right, if we cross multiply here, we will find out that x is equal to 16 times the tangent of 45.9. And when we throw that into our handy dandy calculator and round it to 1 decimal place, we get 16.5. But wait a minute, remember her eye level was at 5 feet, so that means that there's actually a little bit more to the tree right here because she is standing looking at this part of the tree right there. And so the height of the tree is actually going to be the 16.5 feet that we measured plus the 5-foot eye level that she has. So this is going to give me 21.5 feet. So the tree is 21.5 feet tall. Is it tall enough to harvest? Yes. Yes, the tree is tall enough. It's 21.5 feet. Example 8. A 15-foot ladder is leaning against a wall at an angle of 62 degrees with the ground. How high up the wall will the ladder reach? Round to the nearest tenth of a foot. All right, let's draw a triangle. Here's the wall. Here's the ground. And then the ladder is going to be the one that's leaning. All right. The length of the ladder is 15 feet. That's going to be our hypotenuse this time because remember the ladder is the one that's leaning. All right, it is leaning on the wall at an angle of 62 degrees with the ground. That's down here. The ladder and the ground meet right here at 62 degrees. We want to know how high up the wall the ladder is going to reach. That's going to be this side over here. All right, once again, we're going to be using SOHCAHTOA. Sine, cosine, or tangent to solve this. All right, the hypotenuse in this case is 15. It's across from the right angle, so we have that. That means it could be sine or cosine, but we can throw out the tangent. All right, the side we're looking for is over here. This is across from 62 degrees. This is opposite. that means we can throw out the cosine because that has the adjacent side in there. And this time I'm going to be using the sine. All right, so the sine of my angle, 62 degrees, is going to be equal to the side opposite x divided by 15. And if we put a 1 under here and cross multiply, we'll find out that x is equal to 15 times the sine of 62 degrees. And when we put that into our handy dandy calculator, we will find out, when we round it to the nearest tenths place, it is 13.2 feet.